TEDx BeaconStreet, and I'm sitting down with Seth Shipman and Joe Davis, both from George McDonald's Church Lab at Harvard Medical School. Guys, thanks so much for sitting down with me.
Absolutely.
So, for those who might not have seen your talk, why don't you tell us a little bit about it? What was it about?
It was about about new techniques for reading, for using DNA to unlock pages of history up to 500 million years old, and for writing messages into the distant future, like far distant future, after all the monuments and work of human beings have long since passed away.
So, like leaving messages for futuristic, I don't know, aliens maybe in pieces of DNA.
Yeah, so we think that DNA is an incredibly stable media for storing information. So DNA will likely outlast humans on Earth, and so if we would like our information and messages to outlast us, we should be encoding them into DNA.
Great. I want to tell me a little bit about you two, about your dynamic.
George Church calls me a scientist masquerading as an artist, and I think Seth is an artist masquerading as a scientist.
So we actually we share a bay, in a lab, and where I'm doing molecular biology, and actually so is Joe. And he has opened my mind a little bit to more of the poetic and artistic aspects of science, and I try to help out where I can with technical stuff. Although Joe has been doing this for quite a while, and so he's already a bit of a molecular wizard.
Does the art though does it you find it leaking in and helping with the scientific research?
I think absolutely. There's a massive aspect of scientific research that is about creativity, and so if you are not pushing that part of it, then your science is going to be somewhat limited. And so by pushing the creativity in the environment, that makes the science, I think, reach higher levels.
Yeah.
Greatest moment for me is when there's a kind of mesh of science and art. You just see it coming, and it's this particular situation. It's like a Chinese finger puzzle where you can't pull them apart. If you could, then you would have neither science nor art. And, our greatest moment is exactly that, when you can't tell them apart. Uh, I think that's a really nice way to look at both science and art. Art has to describe the whole world, like quantum physics. You can't describe something you're clueless about. Um, we have sort of this. We have this kind of mandate to generalism. You have to, or you're, you know.
A lot to say about it. So now I want you to tell me a little bit about, go into a little more detail about how do you leave a message in DNA?
So, we can now synthesize DNA not as well as we can read it. So we've been able to start sequencing DNA at a very, very rapid pace now. Synthesizing DNA is more difficult, and so we're just starting to be able to synthesize large pieces of DNA. But so you can synthesize it directly. What we've been trying to do more lately is to actually have organisms like microbes carry that DNA in their own genome. So we're looking at integrases, these proteins that will take pieces of synthetic DNA and actually stuff it into their own genomes. That way they carry it with them, they'll replicate it, they pass it on, and it becomes this like much stable, much more long-lasting piece of information.
Yeah, we're fascinated by the fact that that organisms automatically already and for hundreds of millions of years write into their own DNA, and that DNA holds the picture of this history, and that we can actually moderate that. We can help determine what gets written in over long periods of time, and then go back and read it out later.
Yeah, that's really fascinating. The last question here is, so where do you see this going now? This is where you guys are with it. What does the future look like? What are the goals? Where are we going towards? Or do you even know?
I'm interested in creating organisms that can survive on Mars. we've been by default contaminating extraterrestrial environments for more than 40 years, uh, not only with atmospheric probes and planetary landers, but also by flushing our toilets into space. Gemini, Apollo, Skylab, Space Shuttle, and the Russian Soyuz. These things, this material is ubiquitous out there. Nothing that's been returned from space since the 1970s isn't covered with this stuff. And when you discharge liquid into space, it expands violently, supersonically. It explodes, and this expansion causes freezing of ice crystals that are 1 micron to 1 millimeter in diameter. And NASA's own study shows that they occupy every conceivable orbit within 33 months. Some of these orbits are highly eccentric, so in the space of our own generation, we can expect these materials to arrive on other planets. Origin of the species.
Yeah. So, should we be alarmed that possible future alien spaceships, the first thing they're going to receive from us is our waste, like we've just sent out to them?
I don't think we should be alarmed at all. I think that's the first message they're going to get, and it's a reasonably accurate one.
Yeah.
And when you think about it, all of the knowledge that we've gained about molecular biology and the secrets of life have come largely from this organism that came originally from a human fecal sample,
Yeah.
E. coli. It is, Salvador Dali wrote a chapter in his book called Rhinocerotic. He thought it was gold. Maybe it was.
All right. Well, hey, guys, this has been a pleasure. Thank you so much for sitting down with me.
Thank you.
Yeah, and you can check out their entire talk, Chronobiotics, by going to TEDxBeaconStreet.com.